This is Paro. She is so excited for her first day of school. She woke up with great hair, which means most of her hair follicles are in the anagen or growth phase, and very few follicles are in the telogen or resting phase. Not only does she have great hair, but she is also stress-free.
Stress can be difficult to recognize until one has reached their breaking point. In small doses, however, stress can help you complete tasks and prevent injuries. Signs of physical stress include headaches, upset stomach, insomnia, and difficulty swallowing. Physiological stress is a response that challenges the homeostasis of a cell or an organism. Upon immediate disruption of either psychological or physical equilibrium, the body responds by stimulating the nervous, endocrine, and immune systems.
The central nervous system consists of the brain and spinal cord, while the peripheral nervous system includes nerves that carry sensory messages to the central nervous system. The PNS is further divided into the nervous and somatic systems, which is further divided into the sympathetic and parasympathetic systems. Adrenal glands receive messages from the sympathetic nervous system and are responsible for the hormonal regulation of the stress response. The two adrenal glands are located at the top of the kidneys and have an inner layer called the adrenal medulla, responsible for regulating short-term stress response, and an outer layer called the adrenal cortex, responsible for regulating long-term stress response. The adrenal medulla produces epinephrine and norepinephrine. Neurons of the SNS carry a signal from the hypothalamus directly to the adrenal medulla, which signals the adrenal medulla to secrete the two hormones.
In a stressful situation, these two hormones prepare the body by increasing the rate of metabolism, converting glycogen to glucose, increase heart rate, breathing, and blood pressure. Paro may have been able to deal with these short-term stresses, but little did she know about the effects it was having on her body.
When the brain senses a stressor, it signals the hypothalamus to secrete a corticotropic releasing hormone, or CRH, which stimulates the anterior pituitary gland to secrete ACTH, or adrenocorticotropic hormone. ACTH targets the adrenal cortex, which then releases the stress hormone cortisol. When there is too much cortisol, a negative feedback loop occurs, and the hypothalamus stops releasing CRH, and the anterior pituitary stops releasing ACTH. When the immune system is exposed to elevated levels of cortisol in the blood, the components of the system start to degrade. The stressors can affect any part of the feedback loop, which in turn affects the immune system and subsequently the white blood cells. When the white blood cells malfunction due to cortisol, it has adverse effects on the telogen phase of hair growth. The white blood cells attack the hair follicles, which in turn results in excess hair loss.
Loss of stress over long periods of time leads to elevated levels of cortisol in the blood. This in turn leads to malfunctioning of the immune system and hair loss. Knowing how to deal with stress is key to staying happy, healthy, and hairy.